So I just want to spend just a brief period of time talking about different shapes of bones because this is important to understand when it comes to just identifying bones when you're learning the anatomy. Where the bones are located. And this also plays into the characteristics and functions of the individual bones of the body as well. All right. So basically, there's a few different shapes that we can classify bones within. There's what are called long bones, short bones, flat bones, irregular bones, and sesamoid bones. All right. Well, we'll just talk briefly about each of these. Long bones are probably the ones that you guys are most familiar with, that you think about the most. Long bones are basically, well, the name says it all. They're long. Okay, they're elongated bones. And they're long bones with very, very thick, compact middle shafts and very spongy outer aspects. And I'm going to talk about the names of the various parts of the general characteristics of a bone in a little while. But just for now, think of the middle shaft of a long bone being very solid and compact with a hollow center, and then having a very spongy, being very spongy on each end. Okay, and saying so. This is an example of the femur, and then this would be your tibia, right? I keep drawing these bones. Those are the only bones I can draw correct. Well, you can get the picture here, but and long bones, basically, these make up our appendages, your extremities. So, the humerus. Okay, some examples. I'm not going to list them all, but, you can look at some femur, tibia, radius, ulna, fibula. Those are some very common examples of long bones within the body. All right. And, these long bones we use, these are the bones we use. A lot of movement comes from these bones because where these bones come together to form articulations, form joints, and we have a lot of diverse muscle groups around these various long bones. And like I said, we use these for mobility purposes, to get us from point A to point B or to play a sport or whatever it may be. So those are long bones. And long bones, also something to remember as well, is that within the shaft of long bones, you typically find yellow bone marrow, and then in the proximal ends of long bones, you typically find red bone marrow. Okay, red bone marrow, or the hematopoietic tissue. All right, so those are long bones. Short bones, I would really think of short bones as being in your wrist and in your ankles. Okay, your carpals and your tarsals. Okay, your ankle and your respectively your wrist and your ankle bones. Okay, they're just very short bones that are, what these really do is they just make the wrist and the ankles a little more flexible. Okay, because these are very short bones. They're kind of flat with a little bit of a weird irregular shape to them, but they sit in very close proximity to one another. And you have to remember that these bones have cartilage around them as well. All right, especially in the ends where they articulate with other bones, where they form joints. Okay. And so you got this rubbery cartilage sitting kind of in between all these little short bones that sit next to each other. And what they do are these short bones basically slide very short distances over one another. I mean, they're short in length and they don't move very far as well. All right. And like I said, this just gives us a little more flexibility within the wrist and the hands. So basically you can put, that's why, you can put weight on your foot. And your arch can collapse. The bones of your ankle can somewhat slide by each other and make that ankle more flexible, which makes us more mobile as well. All right, so that's the advantage of having a little array of short bones within these areas versus just one solid bone. Okay, so those are short bones, little short bones that slide by each other. All right, and then there are bones called flat bones. Okay. Flat bones, and obviously they live up to their name because they're fairly flat. Okay, and up here I drew a sternum and supposed to be ribs attaching to the sternum. The green is supposed to be the costal cartilage, and the black is the rib itself. All right, so that's use your imagination along with my art here. Sorry, folks. Now, flat bones, basically, these are structured a little differently. The long bones, because, like I said, long bones in the center, the shaft, is primarily compact, a really dense type of bone tissue. And in the end, the proximal and distal ends of the bones have a very spongy inner working, which is what we call spongy bone. All right, and now basically the flat bones are more designed like the very ends of these long bones. Okay, there's like they're like a bony sandwich. Okay, there is a layer of flat bone on each side, and then in the middle there's all that porous spongy bone. Okay, and sitting within the pores of that spongy bone again is more red marrow. All right, so this is where a lot of hematopoiesis takes place. We produce a lot of blood cells from within these flat bones. Okay, examples of the flat bones would be, what I have up here, your sternum, your ribs, your cranial bones. Okay, those are a few examples of flat bones in the body. All right, and so like I said, flat bones are also think about it, these flat bones are covering vital organs as well. So flat bones give us, good physical protection. Because what's interesting about the way flat bones are designed is that, by having these two layers of compact bone and the spongy bone in the middle, that makes them extremely strong bones. Okay, because like let's say the cranium, for example. I mean, you've probably heard or maybe even known someone that's had a cracked skull before, but I mean, it takes a lot of physical force, to get punched in the head or hit in the head by a blunt object for that crack to move its way all the way through the cranium and to actually fracture the skull, all the way through. All right, because what happens, that physical force, you got to remember, there's a compact bone is very, very dense bone tissue. Okay, so that's going to be very good at absorbing a lot of blunt force. All right, but the energy may continue to travel through that flat bone. All right, then it's going to have to go through the spongy bone, which yes is a little weaker, but then that energy has another layer of compact bone to try to get through. Like I said, I mean, it's going to take something very, very strong, like a gunshot, like a bullet traveling at a very high velocity to actually get through all these layers of bone. And for that energy to get down into the soft organs that are underneath those bones. That's why it does take a vast amount of force to break through one of these. All right, and that's the beauty of these flat bones is that they're very strong, but also by having kind of the more spongy center, they also make the bones very light as well. So a good combination of strength and low weight. All right, so those are spongy bones. Flat bones. Oh, sorry, folks. And then basically there's another type of bone called sesamoid bones. Sesamoid bones, realistically, the one way to remember these is that these are bones that are embedded right within connective tissue. All right, and probably the most common type of bone, sesamoid bone you can think of is the patella. All right, the patella. So typically, like I said, these sesamoid bones are embedded right within connective tissue or surrounded by it, and more specifically within tendons. All right, so for example, the patella, which is your kneecap, has four major tendons traveling around all sides of it from your quadricep muscle group. Okay, you've got a tendon going over it, you've got tendons going around the sides of it, you've got one going underneath it. Okay, and then these tendons travel around the sesamoid bone, and they eventually come together to form your patella ligament and insert within the tibial tuberosity, a little bump on the front of your shin, the anterior aspect of your shin. All right, and now basically what these sesamoid bones do is it's kind of cool if they prevent these tendons from getting all tangled up, but they also they're kind of guides for these tendons. Okay, so when one muscle contracts, it's going to pull on this tendon. And it's going to be allowed to pull without being, moving, all over the place. So these sesamoid bones are just little guides for these tendons during movement. And you've got a lot of other sesamoids, very, very small sesamoid bones in your hands and your ankles. Okay, how many you have, that's variable from person to person. But that's what sesamoid bones are. They're just these little, sesamoid, remember oid means to resemble. Okay, it's a suffix that means to resemble, and sesamoid meaning whoever named it this thought they looked like sesame seeds. Okay, so that's what we're saying. Sesamoid is a bone that kind of is shaped like a sesame seed. And like I said, they can range from being as big as the patella to as small as you can barely see with the naked eye. All right, and they are found again embedded within tendons, which is a connective tissue, and just make it easier for tendons to move in a fluid fashion. All right, and irregular bones, basically any shape we can't give to a bone, we just call it irregular. All right, and probably the most common examples of irregular bones are going to be your vertebrae, your facial bones, and your skull. All right, remember your skull is broken down into two major parts: your cranial region and your facial region. Your cranium, all right, most of the bones of the cranium, make up what's called the cranial vault, the area where you store the brain. But there's two bones on the underside of that called the sphenoid bone and the ethmoid bone that make up most of the floor of the cranium. And those are irregularly shaped bones. All right. The sphenoid looks like a butterfly. I can't put a shape to the ethmoid bone. And then vertebrae. What shape can you really give to these? You got circles, some spines, some spinous processes. It's really not a and it has its own unique appearance to it. So basically, bones that just don't have a name of a shape we can give to it, we just call irregular bones. Okay, and again, these are the various shapes of the bones. Make sure you understand these different shapes because it's going to make it a lot easier for you to identify the bones, and it's also going to make it a lot easier because in the next segment I'm going to talk about characteristics of bone, general characteristics of bones. And it's important to understand how each of these individual bones have these characteristics. All right. So